Artemis II is NASA's mission to the moon, launching in early 2026. It'll be the first time that humans have visited the moon in over 50 years, but it's more like a test flight.
For more than half a century, humanity has remained close to home. Since the final Apollo missions in 1972, no human has traveled beyond low Earth orbit. No one has ventured back into deep space. Until now.
Ignition and liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
On April 1st, 2026, the launch of Artemis II marked a historic turning point. Not just because we're returning to the moon, but because we are testing whether humanity can survive, operate, and thrive beyond Earth once again. This is not a repeat of history. This is the foundation of our future. And behind the spectacle of launch lies a mission filled with hidden complexity, risk, and innovation. At first glance, traveling to the moon sounds straightforward. Ignite engines, steer carefully, and come back the same way. But Artemis II takes a very different approach. Instead of relying on constant propulsion, the spacecraft follows what's known as a free return trajectory. This means the spacecraft is placed on a precise path where the moon's gravity does most of the work. As the spacecraft swings around the far side of the moon, gravity bends its path, naturally sending it back toward Earth. No additional engine burn is required to return home. Think of it like throwing a perfectly aimed boomerang across space. This trajectory is not just elegant, it's critical for safety. If the spacecraft were to lose propulsion after leaving Earth orbit, this path ensures the crew would still make it back alive. It's a passive safety system built into the laws of physics themselves. Moments after launch, Commander Reed Wiseman captured the significance perfectly. We have a beautiful moonrise. We're heading right at it. That statement wasn't just poetic, it was literal. During the Apollo era, spaceflight was driven by geopolitical rivalry. It was a race. Artemis represents something fundamentally different. It is collaborative, it is international, and it reflects a broader vision of humanity. The Artemis II crew embodies that shift. Reed Wiseman, commander, bringing leadership and ISS experience. Victor Glover, pilot, becoming the first Black astronaut assigned to a lunar mission. Christina Koch, mission specialist, holding the record for the longest single spaceflight by a woman. And Jeremy Hansen, mission specialist, the first Canadian to travel to the moon. This is not just symbolism, it's strategy. Future missions to the moon, Mars, and beyond will require global cooperation. No single nation will sustain deep space exploration alone. By integrating international astronauts and diverse expertise, Artemis is building the framework for long-term exploration. In many ways, this crew is not just traveling to the moon, they are representing the world. Most headlines focus on the moon flyby, but the most important part of the mission happens quietly on day 5. This is when the spacecraft enters the moon's gravitational sphere of influence. At this point, the moon's gravity becomes stronger than Earth's. The crew is no longer primarily under Earth's pull. They are for the first time in decades operating in true deep space. And here's what makes this moment so critical. The astronauts conduct a full-scale operational rehearsal. They rapidly put on their spacesuits, pressurize life support systems, secure themselves under changing gravitational forces, and practice emergency procedures in real conditions. This is not theoretical training. This is not simulation. This is the real environment where future lunar landing crews will operate. Why does this matter? Because future missions will depend on astronauts being able to respond instantly under pressure. There's no room for hesitation in deep space. Day 5 is where NASA answers a critical question. Can humans function effectively when Earth is no longer the dominant force? If the answer is yes, it unlocks the next phase of exploration. Before Artemis II could even leave Earth, it had to overcome a problem that sounds almost invisible but nearly stopped the mission entirely: hydrogen leaks. The rocket powering this mission uses liquid hydrogen as fuel. Hydrogen is incredibly efficient, but it comes with a major challenge. Its molecules are so small they can escape through microscopic imperfections in metal seals. These persistent leaks, nicknamed hydrogen ghosts, caused repeated delays. At one point, engineers were forced to roll the entire rocket back for extensive inspection and repairs. And that wasn't the only issue. Teams also had to resolve faulty battery sensors and critical safety systems designed to destroy the rocket if it veers off course. Each of these systems had to work flawlessly, because when you're launching the most powerful rocket ever built, there is no margin for error. The successful launch wasn't just a milestone, it was proof that these challenges can be overcome. On April 6th, Artemis II reaches its most iconic moment. The spacecraft approaches the moon, coming within approximately 4,000 to 6,000 miles of the surface. To put that into perspective, that's closer than some satellites orbit Earth today. This maneuver is made possible by a powerful engine burn early in the mission known as translunar injection. This burn propels the spacecraft out of Earth's orbit and places it on a direct path toward the moon. As the crew pass behind the moon, they will temporarily lose communication with Earth. For a brief period, they are completely alone, shielded from radio signals by the lunar body itself. It's a moment that echoes the Apollo missions, but with modern technology and a new purpose. Because Artemis II isn't about landing, it's about proving that humans can make the journey safely. This mission lays the groundwork for what comes next, returning astronauts to the lunar surface and building long-term infrastructure in lunar orbit. In other words, Artemis II is the bridge between exploration and permanence. After 10 days in deep space, the mission concludes with one final test: re-entry. The spacecraft will slam into Earth's atmosphere at speeds approaching 25,000 miles per hour. At these velocities, temperatures outside the capsule reach thousands of degrees. This is where the spacecraft's heat shield faces its ultimate challenge. If successful, the capsule will deploy parachutes and splash down safely in the Pacific Ocean. But the true significance of Artemis II doesn't end with splashdown. It begins there. Because this mission answers a question humanity has been asking for over 50 years. Can we go back? And more importantly, can we go further? Artemis II proves that we are no longer confined to Earth's immediate neighborhood. We are once again a deep space civilization. And this time, we're not just visiting the moon, we're preparing to stay, to build, to explore, and eventually to move beyond it. If you found this insightful, make sure to like, subscribe, and stay tuned, because the next chapter of human exploration is already unfolding, and you won't want to miss it.
Integrity on the Artemis II mission around the moon.